Newton's second law states that the net forces acting on a body is equal to the rate of change of its momentum with respect to time. And momentum is mass multiplied by velocity. Now where the mass is constant, then we can take the mass outside the derivative and we obtain the following expression. So in this case, the net force acting on the body is equal to the mass multiplied by the acceleration of the body. And we can resolve this based on the coordinate system we choose. So in Cartesian coordinates, we can break it up into the sum of forces in the horizontal direction and the sum of forces in the vertical direction. So what we do first is draw a free body with all the forces acting on it. So for example, if we're analysing the block, we isolate it and we draw all the forces acting on it. And when we don't consider the rotations of the block, we treat it as a particle or a point mass. So in this case, there's only acceleration in the horizontal direction because the net force in the horizontal direction is not equal to 0. So in the vertical direction, the net force is 0. So there's no acceleration in this case in the vertical direction. And in general, parallel forces to the velocity vector can change the speed of an object, whereas perpendicular forces change the direction of the object. So in this case here, we have the electric force attracting the electron to the proton in a hydrogen atom, which orbits the nucleus. So we can see that the force is perpendicular to the velocity vector. So the force only changes the direction of the object to keep it in a circular path.